Next up, we have Jan talking about Kafka, Metadata, and KIP-500.
All right. So yes, today we're going to talk about this KIP-500. So if you Google it, you're going to find that it's replaced Zookeeper with a self-managed metadata quorum. So like there's many words in it, like there's Zookeeper, there's Quorum, there's metadata. It's very cryptic. So what it is about? So today we're gonna go through what this KIP-500 is, and the genesis of it, how it happened, where we're here now. And so when the guy is called Jay Krepp, and then at LinkedIn decided to do Kafka, they said, let's build a distributed messaging system. That's so cool. So let's do that. And of course they all knew that distributed systems are complicated. But they say there's nothing to worry about because we have Zookeeper, which is another Apache stuff, and we're going to use that and we're going to be fine. And years after, say no, wait, let's get rid of it. Oops. And so the question is this really an improvement? Because KIP is basically a Kafka improvement proposal, like RFCs in time. So we're going to see through why does this happen? So one point very important is the fact that like certainty is a commodity, which is worth money. It's a commodity; it can be sold. So there's been for us to build predictable stuff, we need to have certainties, and these certainties are building blocks. You can have we all know about compare and swaps and test and set stuff, which are basically courtesies of the chip. Later on, there's been this transaction, which basically Larry Ellison built his fortune on. It's another commodity, and that thing bubbles up in the application layer, and then we do all kind of very nice stuff like banking and shit and whatnot. And so, at the same time, there was this godlike fantasy database, which is super cool. That's a database, which will never. It's centralized, obviously, so there's only one. It never fails. It's transactional. And it's scaling infinitely. So that is super cool. So it's been a fantasy floating around, but also it's a thought experiment in distributed protocol, actually. But we all know that system fails in all kind of very horrible and unpredictable ways. It's like they all fail all the time. So we said the ground now is to go distributed. Yeah, let's go distributed. So we all know TCP, it's a nice protocol, it works very well specified. And so protocol, that rings a bell. So we had already at this time the two-phase commit, which never worked actually. We're trying to get like multiple people to cooperate around a transaction, to modern agreements. And the goal of these is to achieve some kind of certainty amongst a set of agents, which can fail, obviously. And of course, that's the research, did a bunch of stuff, and they devised network topologies and kind of failures, Byzantine failures, like the stuff we have in Bitcoin and blockchain, and so forth, and then the properties are not interesting. And so the latest things. I'm explaining what Zookeeper is now, So the latest in this research is basically we reached these new consensus algorithms. So we've heard of Paxos or Raft. Of course, Kafka had to call it Craft. They had to put a K in front because this is super cool. And so, yeah, the consensus is very simple. It's basically, we have multiple agents. They can fail, obviously. At the beginning of the consensus, everybody proposes a value. Whatever it is, we don't really care. And at the end, so there's a number of rounds, of exchanging stuff here and there and stuff and so forth, yeah. And at the end, all participants were still alive. They decide on the same value. So there's some consensual, basically, adoption of a value. So yeah, the N and F is basically F is number faulty. So they have properties, and we can say, if F is 2, basically, you have this N 2F plus 1 or N, depending on the speed. So you trade number faulty for speed, basically. But this leaves completely aside the the value, like, whatever. It can be a blob, can be anything, yeah? So obviously, here comes the down of Apache Zookeeper, which is exactly doing this. So the idea is basically from transactions. So like now we have like RDBMS, huge database, and now we're going to have like a consensus engine, solving consensus, and then, like as a commodity. So the way that's briefly how Zookeeper works, every data of interest is basically represented by a Z node, so, and data, timestamp, version number, ACL, and stuff. So clients are basically the sets watch on Z nodes of interest, and when the node is changing, they get notified of the change. That's how this works, right? So ZK send notification to watchers. So already a hint, what could possibly go wrong in there, So I will go back to Kafka. So metadata, the metadata, we use them to describe state of dynamic system, possibly dynamic systems, so they change over time. And we're interested in knowing what's going on. So here, it's an example of 3 or 4 consensus applied, and how they use metadata. So one is basically group membership. Who's in the group? It's, like if you think I'm in a group, but I don't think you're in the group, we need to have some kind of agreement on group membership. That's trivial. The other very interesting one is atomic broadcast, which is basically a consensus, an agreement on the order in which, it's total order basically, an agreement, the order on which a sequence of messages will be delivered by every participant of the consensus, which is not trivial. And then state machine applications, atomic broadcast plus a state function agreed upon, so we all know, how the state is changing over time. And obviously we have blockchain, which is kind of the latest, like if you take the Ethereum stuff, then a smart contract blockchain, then the virtual machine solving smart contract is basically the metadata. And then that's basically the object of the consensus. So, yeah. Let's go back to Kafka. In the case of metadata, I put some popcorns because this is a never-ending stuff. So it's basically super messy. They support Kafka clients. Consumer producers, all of these stuff. It's not about Kafka now. Kafka is complicated, right? There are broker. 2 minutes. Okay, yeah. Oh. I'm gonna scrap this one. This is just blah blah blah. So I need to scrap that one because So they have one important thing which is called the controller, and the controller decides everything. So let's go to the point. Straight to the point. So there's only one source of truth, and the news, it's not Kafka. It is Zookeeper, yeah? And whether they want it or not, because Kafka broker don't run the consensus, and the consensus is agreed upon people within the who run the protocol. So they're just client talking TCP, and that's about it. That's the end of the story, basically. Of course So always go straight to the top, yeah. So, Kafka is a distributed system which, unfortunately, has subcontracted its certainty to some other external entity, which is called Zookeeper. And as a result, you cannot give something you don't have. It's like, they promise certainty to the Kafka clients, but they don't have it themselves. And, how can you give something you don't have? That's the point. Check out this Kafka Boom Boom. There's a gazillions of very, very hairy failure cases where, and it can go wrong in many, many different horrible ways. So my point is KIP-500 is not a fix. It's a fix. It's not an improvement. And to finish it. So state of it, there's a lot of version. We don't know whether they're going to come. It's still messy. The good news is Kafka has a nice wire protocol, which is well defined, and actually it's a wire protocol, so everybody can implement it basically, and it's usable. And you have companies now called Red Panda, who basically it's Kafka done right. To a long story short, they don't do Zookeeper, so they implement the RAF themselves. They C++, so there's no JVM stuff, and they Jepsen tested, and that's it. So, yeah. Eh?